In this situation involving the supply of power to outside poles for a semi-truck garage, and given the requirement for 50-20 amps ground fault circuit interrupter receptacles, each handling 1200 watts of continuous load, it's beneficial to consider the optimal approach for wiring and power distribution. A key consideration is whether to utilize centralized feeders or distributed feeders. Centralized feeders involve bringing larger amperage feeders to a junction box on each pole, from which taps are made for individual 20 amp circuits. Distributed feeders, conversely, would involve running individual 20 amps feeders to each receptacle. When evaluating the two options, several factors come into play, including wiring costs, voltage regulation, and maintenance considerations. Using centralized feeders offers several advantages. Firstly, it reduces wiring. Fewer feeder cables are needed, which translates to savings on both materials and labor. Secondly, improved voltage regulation is achieved. Larger feeders exhibit lower resistance, thereby minimizing voltage drop and ensuring a more stable power supply to each receptacle. Thirdly, easier maintenance is facilitated. Centralized junction boxes provide a convenient location for troubleshooting and maintaining the system. Now let's delve into the limitations of tapping. When tapping for multiple circuits from a centralized feeder, it's crucial to observe certain limitations. Firstly, maximum current draw must be considered. Each tap should be rated for the maximum current draw of the attached circuit, which in this case is 20 amps. Secondly, the wire size is important. The wire size for the tap must be appropriate for both the current draw and the length of the tap to prevent overheating and ensure safe operation. Thirdly, tap location is a factor. The tap should be located as close as possible to the receptacle. This minimizes voltage drop and improves the efficiency of the circuit. Fourthly, there is a limit to the number of taps. Tapping for too many circuits from a single feeder can overload the feeder, leading to voltage drop and overheating. With these considerations in mind, a recommended approach can be formulated for a system with 50 receptacles. It is advisable to use centralized feeders and tap for circuits in a manner that optimizes efficiency and reliability. Firstly, bring a 150 amps feeder to each pole. Secondly, use 20 amps taps to create 10 circuits per pole. Thirdly, wire each circuit with number 12 American wire gauge copper wire, adhering to the appropriate ampacity for the load. It is also important to keep the taps as short as possible. This approach provides a reliable and efficient power supply to all 50 receptacles. It minimizes wiring and reduces maintenance costs. The 2008 National Electrical Code or NEC provides guidance on these installations. It's essential to ensure compliance with all applicable codes and regulations. When calculating feeder sizes and tap conductors, refer to the NEC tables for ampacity ratings and overcurrent protection requirements. The NEC also addresses ground fault circuit interrupter protection, which is crucial for receptacles in outdoor locations. Ensure that all receptacles are ground fault circuit interrupter protected to enhance safety. Proper grounding and bonding techniques should be employed throughout the system to minimize the risk of electrical shock. This is particularly important in wet or damp locations. Consider using weatherproof enclosures and fittings for all outdoor electrical components to protect them from the elements. Regularly inspect the system for signs of wear and tear. Replace any damaged components promptly to maintain safety and reliability. When planning the layout of the power poles and receptacles, consider the accessibility of the receptacles for the intended users. Ensure that the receptacles are located in convenient locations and are easily accessible. It's also beneficial to consider the future needs of the facility. Design the system in such a way that it can be easily expanded or modified to accommodate future changes in load requirements. Proper labeling of all circuits and equipment is essential for safety and ease of maintenance. Clearly label all circuit breakers, disconnect switches, and junction boxes. Consider using a color-coded wiring system to further enhance safety and reduce the risk of errors during maintenance and repairs. If the receptacles are intended for use with electric vehicles, it's important to consider the charging requirements of those vehicles. Ensure that the receptacles are compatible with the charging equipment and that the system is adequately sized to handle the additional load. Regular testing of the ground fault circuit interrupter receptacles is essential to ensure that they are functioning properly. Test the receptacles monthly or as recommended by the manufacturer. Keep records of all inspections, tests, and maintenance activities. This will help to track the performance of the system and identify any potential problems early on. If the system includes any lighting, it's important to consider the energy efficiency of the lighting fixtures. Use energy-efficient light bulbs and consider installing occupancy sensors to reduce energy consumption. When selecting electrical equipment, it's important to consider the environmental conditions in which the equipment will be operating. Choose equipment that is suitable for outdoor use and that is resistant to corrosion and other environmental factors. If the system includes any underground wiring, it's important to protect the wiring from damage. Use conduit or other protective measures to prevent damage from digging, frost heave, and other hazards. It's also beneficial to consider the aesthetics of the installation. Choose equipment and materials that blend in with the surroundings and that are visually appealing. When installing the system, follow all manufacturers' instructions and recommendations. This will help to ensure that the system is installed correctly and that it will operate safely and reliably. It's important to use qualified electricians for all electrical work. This will help to ensure that the work is done correctly and that it complies with all applicable codes and regulations. When selecting electrical equipment, it's important to consider the quality of the equipment. Choose equipment from reputable manufacturers that have a proven track record of reliability. It's also beneficial to consider the warranty offered by the manufacturer. A good warranty can provide peace of mind and protect against unexpected repair costs. When installing the system, it's important to use proper wiring techniques. This will help to ensure that the connections are secure and that the system will operate safely and reliably. It's also beneficial to use wire connectors that are rated for the application. This will help to prevent loose connections and other problems. When installing the system, it's important to use proper grounding techniques. This will help to protect against electrical shock and other hazards. It's also beneficial to use ground rods that are of sufficient length and diameter. This will help to ensure that the system is properly grounded. When installing the system, it's important to use proper bonding techniques. This will help to create a low impedance path for fault current and protect against electrical shock. It's also beneficial to use bonding jumpers that are of sufficient size and length. This will help to ensure that the bonding system is effective. When installing the system, it's important to use proper overcurrent protection. This will help to protect the wiring and equipment from damage caused by overloads and short circuits. It's also beneficial to use circuit breakers or fuses that are of the correct size and type. This will help to ensure that the overcurrent protection system is effective. When installing the system, it's important to use proper surge protection. This will help to protect the equipment from damage caused by voltage surges. It's also beneficial to use surge protectors that are of the correct type and rating. This will help to ensure that the surge protection system is effective. When installing the system, it's important to use proper lighting protection. This will help to protect the equipment from damage caused by lightning strikes. It's also beneficial to use lightning rods and surge arresters that are of the correct type and rating. This will help to ensure that the lightning protection system is effective. Regular maintenance of the electrical system is essential to ensure that it operates safely and reliably. This includes inspecting the wiring, equipment, and overcurrent protection devices. It's also important to clean the equipment and replace any damaged components. It's important to keep accurate records of all maintenance activities. This will help to track the performance of the system and identify any potential problems early on. If any problems are detected, it's important to have them repaired promptly by a qualified electrician. This will help to prevent further damage and ensure that the system operates safely. It's also important to follow all safety precautions when working on the electrical system. This includes wearing appropriate personal protective equipment and energizing the circuit before working on it. It's important to be aware of the potential hazards associated with electricity. These include electrical shock, arc flash, and electrocution. It's also important to know how to respond to an electrical emergency. This includes knowing how to shut off the power and how to provide first aid. Proper training is essential for anyone who works on or around electrical equipment. This includes training on electrical safety, wiring techniques, and maintenance procedures. It's also important to stay up to date in the latest codes and regulations. Compliance with the NEC is essential for ensuring the safety of the electrical system. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It's important to consult the NEC when designing, installing, or maintaining an electrical system. Proper planning is essential for a successful electrical installation. This includes determining the load requirements, selecting the appropriate equipment, and developing a detailed wiring plan. It's also important to obtain all necessary permits and approvals before starting work. It's also a good idea to consult with a qualified electrical engineer to ensure that the installation meets all applicable codes and regulations. Proper installation is essential for the safety and reliability of the electrical system. This includes following all manufacturers' instructions and using proper wiring techniques. It's also important to inspect the installation to ensure that it is done correctly. Proper testing is essential for verifying the safety and functionality of the electrical system. This includes testing the wiring, equipment, and overcurrent protection devices. It's also important to test the ground fault circuit interrupter receptacles. It's also beneficial to use a qualified electrical testing company to perform the testing. Proper documentation is essential for the maintenance and repair of the electrical system. This includes keeping records of all wiring diagrams, equipment specifications, and maintenance activities. It's also beneficial to use a computerized maintenance management system to track the performance of the system. This centralized approach, utilizing a 150 amps feeder and 20 amps taps with number 12 American wire gauge copper wire, and keeping taps as short as possible, provides a practical solution, adhering to NEC guidelines for supplying power to these outdoor receptacles. Remember, safety and adherence to codes are of paramount importance in any electrical installation.